Okay, what we're trying to do here is find the largest area rectangle, which can be inscribed in the circle that has a radius of 4 inches. So notice in the picture, if the radius is 4, all the way across would be 8, since that's the diameter. So remember, for these optimization problems, you always need two equations. One equation should always be whatever you're trying to maximize or minimize. I want the largest area, so I'm trying to find the maximum area. So if I look at the picture, I'm trying to find the area of the rectangle. So the area of the rectangle is just x times y. Now you will need a second equation. And I see this rectangle here. I also see this right triangle. So I can set up Pythagorean theorem. I know that for that triangle, x squared plus y squared has to be 64. Remember, whatever equation you're trying to maximize or minimize, we need it in terms of one variable. So I'm going to go ahead and solve this for y. I'm going to subtract the x squared. I'm going to take the square root of it. When you take the square root, you do get a plus or minus, but y refers to the side of a rectangle, so it has to be positive. So now I'm going to go ahead and plug this in here. So now I have an equation that only has x's in it. Okay, anytime we talk about maxes or mins, what do we need to do? We need to take this derivative, set it equal to 0, and find your critical numbers. Now the rest of this we're going to do on your calculator. So in y1, you should type in your area equation, which is this, right? In y2, you should have the calculator come up with the derivative of whatever is in y1, so using this notation, right? And then in y3, plug in your 0. And remember, we only care about where the derivative is equal to 0, so we really should only be looking at this equation, your y2 and your y3. So make sure to turn off your y1 equation and find the intersection and think about what makes sense for your window. Your radius is only 4 inches, and your area is only 64, so x shouldn't really be that big. So I would just set up your x from 0 to 10 and your y windows to go from -2 to 2, because you just need to see the zeros. And you should only see one point of intersection, which is this 5.6568. So that has to be your maximum. And notice it goes from positive to negative. And then make sure you answer a question. It asks you to find the dimensions. So the dimensions of the rectangle are your x and your y. So take your x and plug it back in here to find the matching y. So this would be the matching y value. Okay, the next one, okay, we're talking about cat food. The volume is approximately 14.5, so we know we're going to need that equation. How should the can be constructed so that the material made to make the can is the minimum? So we're trying to minimize surface area. So notice I am giving you a surface area equation. So this is the equation that I'm trying to minimize. So that's what we're going to take the derivative of. The only other equation that we have is that the volume is 14.5. So I know 14.5 is the volume of the cylinder. The equation for a cylinder is pi r squared h. So this is what I need to be in terms of one variable. I would say easiest to solve this for h. And then I'm going to plug this into here. And I'm not going to clean anything up. I'm going to leave it like this, type this into y1, and then have the calculator, again, do the same thing we did in the previous problem. Have the calculator come up with the derivative in y2, and y3, have it find the zeros. And if you do this correctly, you should get an intersection point of 1.32146. Again, it does ask you how should you construct the can, so you need the radius and the height. So you can plug it in here and find the matching height. Okay, number 7 is very similar. You're going to do a right circular cylinder again. So it's going to hold 22 cubic inches. So that's really talking about the volume again. So we know 22 is the volume of this cylinder. Same as equation as above. And we want to conserve the amount of aluminum used to make the can. So we want to keep the surface area to a minimum. So we're going to use the same surface area equation that we had because it's still a cylinder. We have the same equations above. So this is just practice using your calculator. So I'm going to solve this for h again. Plug this in for h. So I have my surface area equation in terms of one variable. And again, you do not have to take the derivative by hand, but you do need to show me this step that this is what you're doing in the calculator. You're going to have the calculator take the derivative and set it to equal to 0. And if you do it correctly, and it only asks you for the radius, I believe you get 1.519.